Terry is planning for his pension. He intends to retire in 35 years' time. He assumes the money can be invested at an inflation adjusted annual rate of 4.2%. So all calculations therefore be based on 4.2% annual growth rate. Terry wants to have a fund from the date of his retirement to give him a payment of $30,000 at the start of each year, for the start being the key word, for 25 years. He uses the sum of a geometric series to calculate the value of the fund required on the date of retirement. Okay, so on the start of year one, his cost is going to be 30,000. Okay, so the start of year one, he gets 30,000. 30,000 today is still worth 30,000. Now, in 1 year's time, we're basically using the formula P equals F over 1 plus I to the power of T. Now, 1 plus I is going to be 1.042. Now, at the end of the start of year 2, it's going to be 30,000, and this 30,000 euro is in a year's time. That's going to be divided by 1.04. At the start of year 3, this 30,000 euro is 2 years old, so it's going to be divided by 0.42 squared. And then you're going to have a sequence until the last year, and in the last year you're going to have it divided by, what's it going to be, divided by 24, because this amount of money will be 24 years from now, and it therefore costs a lot less today. So what we have here is a geometric sequence. Our A value is 30,000. Our R value is going to be 1 divided by 1.042. We'll let that equal to B. Our so Sn equals A into 1 minus Rn all over 1 minus R. Now, how many payments did we make in total? Well, it's over 25 years, so it's going to be 25 payments. So Sn therefore equals 30,000 multiplied by 1, and now we have to do star what B is, so it's going to be 1 divided by 1.042, and we're going to shift star as B. So it's going to be 1 minus B to the power of n, and now n value is 25 years, all over 1 minus B. So we're going to get is 30,000, and this 30,000 is going to be multiplied by 1 minus B to the power of 25, and then it's all going to be over 1 minus B. So he has to invest 478,184.59. Okay, so that's his amount he has to invest. Done. Terry plans to invest a fixed amount of money at the start of every month. So the start of every month, in order to generate the fund calculated in part 1. His retirement is 420 months away. If Terry makes 420 equal payments of P from now until retirement, what value of P will the fund he requires? Okay, so he has to generate his 478,000. So he has to generate 478,184.59. Okay, now what we got to find out is the interest rate. Now he's going to be doing it per month. So this means that 1 plus I to the power of 12 equals 1.042. Therefore 1 plus I will equal the 12th root of 1.042. The 12th root of 1.042 that's going to be my new B value. Shift star, and that's going to be my new B value. Okay, so what we know is that he's investing it at the start of every month. So we're going to let this amount be P. Now, at the moment, his very last investment, okay, his very last investment will be 1 month, will be the start of December on the last year. And at the start of December on his last year, that will accumulate 1 month's worth. So it'll be XB1. The payment before that will be XB2, will accumulate 2 months. XB3 will be the third payment, accumulates 3 months. Now, if we go to the very end, his very first payment is 420 months away. So it will accumulate 420 months worth of interest because he put it in at the start of the year. Okay? So now we have a sequence here, which is S of n equals a into 1 minus Rn all divided by 1 minus R. Our a value is xb and our R value is b. So therefore S of n is going to be xb into 1 minus b to the power of, now n is going to be 420 because there's going to be 420 payments, all divided by 1 minus b. Now this part here is the part that goes into the calculator. Okay, so we put this into the calculator. So what we get is alpha b into 1 minus b to the power of 420 all down by 1 minus b. And what we get here is 940.96. So 940.96, I think. $940.96. X will equal this amount here to 478,184.59. So we're going to get our 478,184.59. We're going to divide it by our answer, and we're going to get a monthly rate of 508.19. So our monthly rate is 508.19. Now, if Terry waits 7 years before starting his pension investments, how much will he then have to pay each month in order to generate the same funds? So he's waiting a bit longer, okay? So this means that I'm just going to steal this sequence here. Okay, so I'm just going to copy this sequence here that I used in the last question. So this time it's going to be 84 months shorter. So this 420 is no longer 420, it's going to be 84 months shorter. So 420 minus 84, because minus 7 years is going to get you 336 months at the end. Okay? And then we can pretty much steal exactly the same formula of the last question, because it's the same question except n now equals 336. So what we have here, that's it there, and then we can just put this as 336 and put all of this into the calculator like last time. So this part here is what goes into the calculator. So what we have is there it is there. We can reuse it using the calculator, and then we can say that's 336. And now we're going to get 632.39. X will equal this amount here, 478,184.59. We're going to divide that number to 478,184.59. And that's going to be divided by our answer, and we're going to find out that x equals 576.15. 756.15. Okay, so once again, Grania is planning for her pension. She intends to retire in 38 years' time, so it's going to be 38 years' time. She assumes that the money can be vested in inflation adjusted for 3.8% So all calculations should be on a 3.8% grow rate. Grania wants to have a fund that could, from the day of retirement, give her a payment of $35,000 at the start of each year for 27 years. Use the sum of a geometric series to calculate the value of the date of retirement at the fund required. So it's the start of each year. Okay? So the cost is going to be, now remember, we're going to use P equals your final value over 1 plus I to the power of t. Now, if you get your first payment is going to be €35,000 that's received at the start of year one. So this is the start of year one. It's worth the same amount now. You're also going to receive $35,000 at the end of year one, or sorry, the start of year two. At the start of year two, it's going to be worth less than it's going to be worth less now than it is in a year's time. So we're going to divide it by 0.38 to the power of 1. The third one is the start of year 3, and that's going to be in 2 years' time, which is over 1.038 to the power of 2. We continue this series on until we have the start of year 38. Now, the start of year 38. Oh, wait a second. She tends to retire in 38 years' time. So she assumes that money information. Oh, excuse me, guys. She's actually only investing for 27 years in this question. So it's 27 years. So she's going to be investing for 27 years. So the last one is going to be, her last payment is going to be at the start of year 27. And at the start of year 27, it's only in there for 26 years. Okay, so this here is 27 payments in total, n equals 27. Now, what we're going to have is our A value is 35,000. Our R value is 1 divided by 1.038. So we can just do 1 divided by 1.0038. Store that as our B value. Okay, once you store that as your B value, you're then going to get your SN. SN formula equals A into 1 minus Rn all over 1 minus R. So Sn therefore equals 35,000. 1 minus B to the power 27 all over 1 minus B. Therefore Sn equals 35,000. 35,000 multiplied by 1 minus B to the power 27, close bracket all over 1 minus B. And what we get here is 606,789.09. So 606,789.09. Okay. Now, if Grania plans to invest fixed amounts of money at the start of every month in order to generate the fund calculated in part 1, her retirement is 38 years away. If Grania makes 546 equal payments, so that's 38 multiplied by 12 to get your 556. What value of P will she required to give the fund she requires? So the fund she requires is 606,789.09. She wants to invest P at the start. Is the start of every year? Start of every month. So it's the start of every month, which means that our I value, so 1 plus I, we're going to do it monthly, equals 1.038. Our new B value is 1 plus I, which is the 12th root of 1.038. So this 1.038, we need to get the 12th root of 1.038, and then we're going to save that as B. Now, it's the start of every month. Okay, so if she does it at the start of every month, our last payment is going to be the December at the end of the year, and this payment, P, will have 1 month's worth of interest. The payment before that will have 2 months worth of interest. And the very first payment you make will have all 456 months to gain interest. So that's PB 456. This is 456 separate payments. So what we're going to do now is we're going to use a series. So our A value is PB, our R value is B, our SN formula is equal to A into 1 minus Rn all over 1 minus R. Therefore our SN ends up to be PB into 1 minus B to the power of 456 all over 1 minus B. This part here is the calculator part, excluding the P. So what we're going to get, put into the calculator, we're going to get B into 1 minus B to the power of 456, close bracket, divided by 1 minus B. What we get here is 1007.27. So 1007.27p equals our number of 606,789.09. Now we're going to divide that number by 1007.27. So we get is 606,789.09 divided by 1007.27. And what we get is our monthly amount is 602.41. Okay. Now the part after that, if she waits 4 years before starting her pension investment, how much will she then have to pay each month in order to generate the same pension fund? Well, what I can basically do here is I can copy this full question. I can copy all of part 2. So if I copy all of part 2, and what I have to do is I have to do 4 years less. We have 4 years less time. Okay? So what we got to do, it's no longer 456 months. You got to take away 48 to get 408 months. Okay? So this here, anywhere we see n equals 456, we change it into 408. So we have 408 here, 408 here, okay, and then you just go back up to the calculator, and then you just change this part here into 408, press equals on the calculator, and you get 823.01. So 823.01, 823.01p, this number equals 606,789.09. Divide that number 606,789.09. Divide that by 823.01, and what you're going to get is a value of 737.28. So your monthly investment, if you start 4 years later, is 737.28, which is a larger monthly value than 602.41, which is expected.